All right, now I'm going to go to share with my document camera. Move my little light a little bit over. Move this way. So we got to remember the things that we need to use to describe them. Remember, we need to use something with talking about parallel lines, and we don't necessarily have to say acute or obtuse, but we need to know if there's right angles in this. So we're going to be describing shapes using right angles if they have them, parallel lines, talking about how many angles, how many sides, how many vertices, and talking about what is it about opposite sides, the sides that are on the other side of the shape, and adjacent sides, the sides that touch. Okay. Now, what is it that you call any shape that has four sides? What do we call any shape that has four sides?
Quadrilateral.
A quadrilateral. Okay. I've got this thing that's called a quadrilateral hierarchy. Oh, that's a tongue twister. I was messing up on quadrilateral when I was trying to focus on how I'm going to pronounce hierarchy. That just means that it's talking about how they're connected. Okay. So a quadrilateral is any shape that has exactly how many sides?
4.
Yes. Okay. Now I got to get me some extra papers because it goes down and it shows more than one thing. Okay, so we're going down and we're going to look at quadrilaterals. It's like a tree map. Types of quadrilaterals. Whoops, I meant not to show that. So what's the name of this one?
Trapezoid.
Trapezoid. There it goes. And what is it that we could describe that is a trapezoid? Using those things where we're talking about sides, angles, parallel lines, right angles. What would we say about a trapezoid? Let's look at the sides. If this one kept on going and this one kept on going, the opposites of the right and left, would they, if they kept on going, would they cross over?
Yes.
So they're not parallel. But what about the top and the bottom? What could you say about them?
They're parallel.
They are parallel. So that is a set. A set is always two of something. So it has one set of parallel sides. Because this one happens to be top and bottom. If I turn this paper sideways, it'd be like left and right. It just depends on how it's setting. But it's just one set. And a set is like a pair, two of something. Okay. What do you call this one?
A parallelogram.
Let's check and see. Yep, a parallelogram. Now, how would we describe a parallelogram? Look at what we said about the trapezoid. It's got one set of parallel lines. Notice this one's called a parallelogram. What could we say about it?
It has two parallel sides.
It's got two sets of parallel sides. And they're always the opposite of each other. So this left and right, they would keep on going, and the top and bottom would keep on going. They would never cross. See, do we have another one over here? Oh, yeah. What do we call this one?
A kite.
It's called a kite. Now, what can we say about a kite? It's the harder one because we've not really looked at it that much. What we need to know is this angle and this angle the same size? If I was to pick this up and lay it on top of that, would the lines match right here as those match right there? Let's go this way. Is this a acute or obtuse angle right here? Remember, obtuse means it's wider than what a piece of paper corner would be, and acute is smaller. So looking at that, would you say that angle at the top is more obtuse or acute? Does it look more like this one? We'll put it that same. Does it look more like that? Or more like the acute one? I'm trying to make the angles be the same.
Obtuse.
It's more of an obtuse angle. Then what about this one down here? Is it acute or obtuse?
Acute.
Acute. Okay. All right. So they are not the same. But what about this side and this side? Do those look like they're about the same size?
Yes.
Okay. So it's got one set of equal angles. Just one set of equal angles, and they're across from each other. Okay, that's all you'll need to say for a kite. Now, let me get this paper under here. Now we're going to go down, and with trapezoid, all it did was add a new one. It's called isosceles trapezoid. It means that it looks just like the block does. And that this side and this side are the same length. You notice how this one's shorter and that one's a little bit longer? It's still a trapezoid. But isosceles just means that they're the same length on either side. You'll learn that later on because when you start doing geometry and have to do formulas, you'll have to know what an isosceles trapezoid and isosceles triangles are. So that's something for in the future. So don't worry so much about it. The only thing you need to know is the same thing as we have up there. One set of parallel lines. All you need to know with that one. Okay? So now let's go over here. And we have a parallelogram, but it's a special kind of parallelogram because this one still has two sets of parallel lines, but it's a rectangle. What else can we add about this that makes it different from a parallelogram? That makes it a special parallelogram. It's still a parallelogram. I'm going to put it in here that it's a parallelogram. And it's got something just that makes it just different than that one. Think of the angles now. When you get to a rectangle, you start telling what kind of angles it has.
The rectangle has right angles and the parallelogram has acute angles.
Yeah. So this one has 4 right angles. And I'll get my little red pen. Remember, you put a little square in the corner, and that means it's a right angle because it makes it look like the corner of a piece of paper, a little paper that's stuck in there. All right. Now we're going to come down here And this is another special kind of parallelogram. So I'm going to write that it is a parallelogram. And it's got width, but it's not about the angles. It's something about the sides. What is it that makes this parallelogram look a little different from that one? They both look like they're kind of going at an angle, like they're a box that's been squished. But think of the sides of this one. What's the difference between this one with its sides and this one? Are all the sides the same? Same what?
Length.
Say a little bit louder.
Length.
Length. Parallelogram with 4 equal sides. And when we say equal sides, we mean in length. What kind of parallelogram is this? Does anybody know the name of this one?
Rhombus.
Rhombus. Okay. Now we're going to come down here. And now we're going to look at a shape that is a rhombus, and it is a rectangle, and it is a parallelogram, and it is a quadrilateral. When you go down, you could say this one's a rectangle, but it's also a parallelogram, and it's also a quadrilateral. A rhombus is also a parallelogram, and it's also a quadrilateral. But here we have one that you could say it's a rhombus, rectangle, parallelogram, and a quadrilateral. What is that shape that we can say is all of those before I even show it? Anybody got a clue what that mystery shape is?
Square.
It is a square. Because if you look at a square, does it have 4 equal sides? Yes. Does it have 4 right angles?
Yes.
Yes.
Angle. And does it have 2 sets of parallel lines?
Yes.
Yes, so that's why it can be all of those, because it is a parallelogram that has, and I'm going to bullet all of them, 2 sets of parallel lines. I don't know if I can get all this parallel sides. Then I look at this one, 4 right angles and 4 equal sides. Let me get my red pen and I do this because it is right angles in all of them. So that's why a square is a rhombus, because it does that 4 equal sides. It is a rectangle because it has 4 right angles. And it is a parallelogram because it has 2 sets of parallel sides. And of course, it's a quadrilateral because it has 4 sides. I thought that was neat to see how you can make sure that shows how a square can be all of those. Okay. All right. What is our time? We're doing pretty good with time. All right, so I'm going to do a quick show. You tell me what this is. What's the name of that one?
Trapezoid.
Trapezoid. What is it that we say a trapezoid has? What is its, what did I like? Think about what I wrote inside of the shape just now. What do we say it has? What's the attribute of it?
2 sets of parallel lines.
It's not 2 sets, it's 2 lines of them, but it's just 1 pair. So we say 1 set. If I said 2 sets, it would be the top and the bottom and the sides. Okay. What about this one? What's the name of this shape when it's this direction?
Square.
Square. But what else can we call it? It's a
Parallelogram.
Rectangle.
It's a rectangle. It's a parallelogram. What else can it be? Let me turn it this way. That'll kind of help. What else can you call it?
Rhombus.
A rhombus. Yes. Okay. Is that a quadrilateral?
No,
Why not?
it's because it has 3 sides.
That's right. I'm going to put some in there that's not it. I'm going to put some strange looking ones in here. What about this?
Yeah.
Yes.
What's the name of it?
Rectangle.
Rectangle.
Rectangle. What does a rectangle have?
4 sides.
4 sides. What makes it different from the others? It has to have to be a rectangle. Think of the angles.
4 angles.
4
Yeah.
angles.
What type of angles to make it be a
Right angles.
has to have 4 right angles. Okay. And it's also a what? Can be called a special.
Square.
No. Square is below it. Got to go what was above it on that chart. These sides will never cross. And these sides would never cross. What do you call it? Where both opposite sides, 2 sets of parallel sides. The word parallel is really big in this name. So we have a rectangle here, and the rectangle is below the. Uh-oh, cat's got y'all's tongue.
Parallelogram.
Parallelogram. Okay. What about this one? Oh, it's hard to see. Let me put it, see if it shows up better there. There, it shows up better when it's on that brown. Oh, what was that?
Rhombus?
It's another rhombus. It's just a little bit smaller, squished down. But a rhombus is a shape that, think of this side and that bottom side. They would never cross, and these would never cross either. So I took a rhombus and I squeezed it down, and the bottom, top and bottom went down like this, and then this squished down like it was made of clay. It's a rhombus. Okay. What about that one?
Parallelogram.
Parallelogram. Okay. But it's also something else, because does that side, and that side all are the same length? It's a special kind of parallelogram.
It's a rhombus.
It's a rhombus. There we go. What about that one, guys? What quadrilateral is that one?
That one's not
Circle.
a quadrilateral.
Yeah, but is it a quadrilateral?
No.
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 Is it even a polygon?
No.
Because why is it not a polygon?
It has no sides.
No sides. And it's curved too. Is that a quadrilateral?
No.
Why not?
It's because it has more than 4
Yeah.
sides.
It's got 1, 2, 3, 4, 5, 6. What do you call a shape? It's got 6 sides.
Hexagon.
Hexagon. Okay. What about this one?
I can't see it that well.
I know it's hard. Let's see if I move that.
That's a quadrilateral.
Is it? Oh, yeah, because it's got 4 sides. What kind of quadrilateral is that?
Square.
Now, it kind of looks like it's the same length. But watch when I do this. I'm going to measure where this top and bottom is, and if I turn it around, does it match? I know it's hard to see.
No.
It doesn't match.
No, that doesn't match.
So it's not a square because they all have to be the same size. So if it's not a square,
It's a rectangle.
A rectangle. Put that in there because it's kind of fooling you, isn't it? I do that to measure out things and double check myself sometimes and turn it around and go, oh, no, they're not the same length. All right, guys. Let me stop the recording. First, I have to stop share. Well, I think I can stop recording first.